functions. So, just gonna underline that. Functions. Okay, a function is something that takes an input function and it gives you an output. So you can kind of think of it like a little factory. There's the function factory. Okay, so just so you kind of see an example of what I'm talking about there. Let's say we have a function, so they're written like this. So your function is f and it's inputting the value x. And then this happens. X cubed minus x plus 2. And then the question would be, find f4 and f10. So if we look over here, we have fx, and here we have f4 and f10. So the only difference here is we've replaced x with 4. So I'm going to just write next to it x equals 4. And then here fx, f10, so we've replaced x by 10. X equals 10. So in our factory function for this one, f4, we're inputting the value 4. So x is 4. So anytime we see an x, we're going to write 4. So 4 cubed minus 4 plus 2. And that equals, if you do that calculation, 62. Okay, here for f10, so where x equals 10, we've replaced x with 10. Anytime you see an x, you replace it with 10. So 10 cubed minus 10 plus 2. And the answer to that is 992. So that's just your basic function factory. Now we're going to look at some things you can do when you have two functions, and then we'll go on to more examples. So if I have two functions and I want to turn them into one function, this is called composite functions. And that is combining functions. So composite functions is combining functions. So it looks a bit like this. So you have your function f and your function g. So that's them combined, or people write that as that. You can take any functions. You could have h and g. So that is what a composite function looks like when you combine a function. And the thing you have to be careful with here is which part you do first. So it will give you two functions. It will give you f and it will give you g, and then you'll have to combine them. And the trick here is, even though you write it down second, this is the one you do first. And then you kind of f hugs it. It's a bit like spooning, really. You've got your little spoon and big spoon, and little spoon goes first, and then this one goes second. And I'll show you what I mean by that with an example now. Okay, so, and important thing to note is f of g of x does not equal g of f of x. Okay, so example, let's have the function f of x equals 5x minus 3, and g of x equals x over 2. Now let's find f of g of x, which is f g of x. So we know from here, little spoon goes first, so that's g of x. So we have f, and then just going to put in there, substitute, so we have g of x here, and I'm just going to put g of x in. I'm just going to copy that in. So g of x is x over 2. Okay, and now if we look at that, we have f of x over 2. So here we've got x, we're replacing the f of x here with f of x over 2, so x equals x over 2 in there. So anytime we see an x, we write x over 2. So f of x over 2, So we have 5, I see an x, that becomes x over 2 minus 3. I hope that makes sense. So now let's try putting g first. So that is g of f of x. So first of all, we see f of x here, and we've already got that here, so it's the exact same thing. We're just going to copy that in. So we have g of f of x, which is this, 5x minus 3. And now, if we're comparing this with our g of x, oh, I should really use a different colour. Boo, boo, boo. If we are comparing this g of 5x minus 3 with this here, so we've now put in, instead of x, so we've got x, we're going to have to substitute 5x minus 3. So anytime we see an x, we have to replace it with 5x minus 3. So our input is 5x minus 3 in the factory, that's all it's saying. So g of 5x minus 3 is, so g of 5x minus 3 is, so we have x here, so that's getting replaced with 5x minus 3, and then that whole x is divided by 2. So I hope that makes sense. Let's now have a look at inverse functions. So if I have a function, it has an inverse. So if I have f of x, there exists an f to the minus 1 of x, and this is the inverse function. And we can work these out using some steps. So the first step is you write down x equals f of y. The second step, we'll have a go at this in a minute, is rearrange, make y the subject. And then the final step is, when y is the subject, replace y with f to the minus 1 of x. Okay, it's probably easier to practice this in an example, so then you'll see what's going on. So here we have our example. I'm going to take the function f of x equals 5x plus 2. And I want the inverse. So following our steps, step 1, write x equals f of y. So what is f of y? X equals, so in here, we've replaced x with y. So x equals y. Anytime I see an x now, I'm going to write a y. So I've got f of y, so 5, I see an x, it's now a y, f of y, plus 2. Step 1. Step 2 says rearrange and make y the subject. So I'm going to go over here for step 2. So here I'm going to get rid of this 2. When I take it over there, it's plus 2 on that side, so it's going to be minus 2. X minus 2 equals 5y. And then I've got 5 here, and when I take it over there, it's multiply on this side. I'm going to do the inverse operation and divide that side. So I have to divide all the terms by 5. So I've rearranged, and y is now the subject of my formula. Step 3, simple enough, replace y with f to the minus 1 of x. F to the minus 1 of x equals, and then that's instead of y, divided by 5. I don't know if you can see that. Anyway, it's x minus 2 divided by 5. Okay, now let's just see if that works, so we can check this. So let's say I put f of 2 in. So what is f of 2? So that would be 5 multiplied by 2, which is 10, plus 2, which is 12. Okay, now let's say I put, so that would be in my thing, I've gone 2 into the factory, and I've come up with 12. So f to the minus 1 would work the other way. So let's say I put 12 in, so that's f of x, and this is f of to the minus 1 of x, this is the inverse. If I put 12 in, I should get 2 out, and that's how I'll know. So let's say I do f to the minus 1 of 12, see if we get 2. So 12, so f to the minus 1, 12, x is 12 minus 2 divided by 5, that is 10 divided by 5, which is 2. So therefore we know our whole factory works and we've got the answer correct. So that's an inverse. Okay, so composite functions, h of f of x, h of f of x. Little spoon goes first, so this part here, f of x, we just copy down. We've got that in the question, so we've got h of 20 x squared plus 1. Okay, now we're looking at the difference between, so we've got h, our function here. So x is now 20x squared plus 1. So what does that become when we put it in here? So we've got h of x, but we haven't got h of x, 20x squared plus 1. So that is going to be, anytime we see an x, we're going to replace it. So in here, instead of x, we have 20x squared plus 1 divided by 2 plus 1. Okay, and now if I wanted to find h of f of 1, I found h of f, so now I need h of f of 1, so I'm going to put 1 in, so instead of x I've got x equals 1, so let's put 1 into this equation here, so we have 20 times 1 squared plus 1 divided by 2 all plus 1. So 20 times 1 is 20, plus 1 is 21, 21 over 2 plus 1, 23 over 2. So I want the inverse of g of x, which equals 10x squared plus 1 all divided by 2. So the step 1 was do x equals f of y. So let's do that. So we can go x equals, I'm going to change that to a g in this case, g of y. So x equals, and instead of every time we see an x, we're going to put a y, 10 y squared plus 1 over 2. Step 2 was rearrange y, the subject. So I'm going to do that now. So if I rearrange, I want to get the 2 up here. So if I divide on this side, it's going to take it over. I'm going to have to multiply on that side. So 2x. I've got an annoying 1 here, so it's plus 1 that side. So I'm going to do negative 1 when I bring it over. I've got a 10 in the way here, it's multiply on this side, so it's going to be divide on that side. So I'm going to divide the whole thing, not just one of them, not just one of the terms. Okay, and then I've got a squared here, so the inverse operation over here is square root, but it's going to have to be plus or minus 2x 1 over 10 equals y. Okay, then step 3 was write y as g to the minus 1 of x. So that one's the simple one. So instead of the here, we're going to put that as g to the minus 1 of x, and then plus or minus, copying this out, square root of 2x minus 1 divided by 10.